Hello. I can't see you, Joe. But I hope you're all good. It says I'm live and the sound's working. So yay, g'day. Excuse me. All right. Well, I'm going to start. I'm going to share the screen. And we're going to go into the stuff. All right. So what's happened this week was pretty cool. Hope you can see. This is to looking about the future of outdoors, because that's the future, because its energy costs is too high. So look at that. So you can keep a field alight. You can get a few flips per year just by implementing a few different systems. And look at this one. This is amazing. I thought, wow, this is going to be replicated one day soon. It's a good way to keep it in veg stage while you're in the outdoors is in the phase of the winter phase, I suppose you could say. So the lights are all right. And this is something cool. This is to do with the pesticides and the heavy metals that are actually in cannabis. And it was a study that was carried out from 31 samples. This is in Italy. And they did some tests to see what sort of pesticides and heavy metals and things were in it, contaminants. And it was pretty interesting. It's not good for the poor Italians. For these samples, the determination of it was 154 pesticides showed 87% of the samples were contaminated with fungicides or insecticides. So this is supposed to be blooming medicine, and so you're smoking or vaping or inducing fungicides and insecticides. Yeah, good medicine. The stuff they found mostly was spinosad and cyprodinyl. And then there was little bits, trace elements. They found metals in range of from 1 to 100 micrograms, like arsenic, cadmium, really, really bad selenium, and they all exceeded the US limits of inhaled cannabis products. So these contaminants were intrinsically toxic. Not very good. Poor people. So yes, it's a big thing for, clean cannabis. And even the LPs struggling to do it. So, yeah, this is pretty cool. This shows the frequencies or the oscillations of a plant. And I found it interesting with the different stages that it goes through, with the different times that it has. So if you hook it up to an oscilloscope, put the little probes in, like you did back in science in high school or in elementary or something, you'd get these little bar graphs happening, little sine waves, and you can see the different frequencies when they happen. And this was a test that they did with calcium, and it's just the different line over here represents the scale on the time frame. Sorry, my eyes were closed like 30 minutes ago. This is so difficult. I'm not trying. Hang on, let me read here for the thingo. It's to do with the calcium. And the root hairs down here, it says their periods were 30 seconds, but it's got a minute scale. Odd. The pollen tube growth rate was at 50 seconds. Where's the pollen tubes up here? So every cycle that it went round, it grew every 50 seconds. It grew. That's what that's suggesting to me. Microbial symbiosis. Right, good on you. The guard cells. So inside the stoma, in the guard cells, the oscillations were noticed every 3 minutes from calcium chloride treatments. The root circumnavigation of period. Righto. That's not to do with our plant. That's to do with it swells around looking for root tips. The root lateral formation. Oh, it was every 6 hours. That's pretty cool. Where's that root formation? Root hairs, not lateral roots. Here you go. So every 6 hours it put out the primary root and lateral root. So every 6 hours it branched off, chink, and put out another one, chink. Little pericycle cells on the side of it. Anyway, next thing. Oh, is that it? Stop sharing. Oh, yeah. because I want to go over the importance of soil nutritional management and soil and plant relationship. Holy mackerel, it was so cool. There's been some really good stuff. My grad uni started, and oh, hello. G'day, everybody. Palature Bro, Mongol Stoner, Supreme Great, Jeff Paparella, Beauty and the Beast, and Lene M. All right, I'm going to continue sharing this soil science and this plant relationships within it. It's pretty fascinating. I'll skim across it too, so I don't want to bore you. Week 3. I'll just go entire screen. Show me this one. Yep. All right. Where's the buttons? We don't want to pass. This is down the bottom. It takes about 500 years for an inch of topsoil. So 2.5 centimeters of topsoil takes an inch to form, but it takes 1,000,000 years for the rock to weather and to form the minerals. So the minerals to form to weathering to first is 1,000,000 years, and then it takes 500 years after that for it to develop. Soil health. This is pretty cool. I'm going to get into it. You'll see soon, because this goes in. This is a very in-depth week of soil stuff that I did. Soil indicators. Yep, you're getting. No, this is the one I want. So the 3 things: the physical properties, chemical properties, and biological properties that are in for soil health. Main things: microbes, and then your chemical properties are all to do with your electrical conductivity and your pH and nutrients, and the physical bits are all the water, what goes on about the bulk density of it, like how strong it is, what the constituents of the physical properties of it are, how much organic matter is in it to retain the water, and for the CC, soil formation. Yeah, that's good. I'm going to skim through and just get to the bits that are really relevant, because there's a shitload here. Fertility is measured by the amount of chemical elements and compounds required for plant health. Yes, soil fertility is the nutrients amounts. Productivity is down here, the management and the climate factors, as well as the productivity and the nutrients. Not the productivity. Sorry, I did smoke before it. Woohoo! Balancing. This is the thing you've got to do. And just like that video I put out before, it's about balancing it, and your inputs. You've got to, inputs have got to equal to your outputs, and then you'll have success. You'll keep the soil health really high and your substrate cell health high, and the environment too, whilst getting the same yield. This shows, where do we start? So the timeline down the bottom from when it starts. So up the top left is degraded crops, and it goes to restored. So you see soil fertility, the line up here. So when you got good action up top in the phylosphere, when it's growing well, you can see everything is in check because it just works well. Everything cycles perfectly and is in symbiosis. The microbes, etc., they've all established themselves. When everything's shit over here, look at that. You get heaps of nutrient erosion, nutrient loss and erosion. The law of the minimum, whatever the lowest fat element is in your cycle will be the best result that you can get out of, is what this states. Here's a few examples on how to achieve that, how it's just what I said. That shows it there. So at the top, so the NPK, so your phosphorus is the lowest, so it's about the best you're going to get. Over here, mag sulfur is lowest. That's about the best you're going to get. Law of diminishing return. Actually, I'm not going to go through a list. That's really technical. It basically shows on here, Jesus, that how much you put in. This is nitrogen. So if you put a shitload in, is it going to work? Well, fuck no. Look over here, the yield. So it only works the law on diminishing return. So you put a little tiny bit in, and then it works. If you go too much, it gives it like a luxury sort of feeding where you won't get the maximum out of it. essential plant nutrients. This changed everything. This shows you how important friggin' science is. This is written in 2022, this course, and this is new updates for me. It used to be, anyway, CH&O make up 95% of the dry matter. Yep, it's 45% of carbon, 45% oxygen, and 5% hydrogen. And they all come from the air for the plants. And you got your primary, secondary, and then your micros, and then they've broken them up again to your ultras. So this is all new shit. Your primaries, yeah, you know about them. Oh, actually, well, they're NPKs. And then your secondaries are your CalMag sulfurs, and it used to be silicon, but that's broken into a different bracket now. Micro trace elements, yep, that hasn't changed. They're all under 1 microgram and 1 ppm per kilo. Look, they got a new one, Ultra. So Ultra has your molybdenum, chlorine, and cobalt. And then they got the beneficials where they put, so silicon and sodium, palladium, they used to be back into the new table, and they've taken them out and they're beneficial because only some species works good with this. And I can tell you, silicon works well with cannabis. And we do need some sodium for some sodium channels. Oh no. And here, this is the actual ion form that the plant uses. So nitrogen, so you've got your CH&O, NPK, CalMag, sulfur, and then now your micros down there. So we'll take nitrogen. So nitrogen, you got about 7 different forms. You know, you got your urea, your nitrate, your God, it's way too early. Anyway, this is nitrite, and this is ammonium here. Oh, it says it there. That's your forms that your plant is ready to absorb. All your other forms are not readily uptaked, so they've got to be unlocked by microbes. So that's when they say you go and feed it. Yeah, feed it nitrogen. Is it the right form of nitrogen for the plant to uptake? That's what that means. And these are the actual ones that you want to. So you can go and give urea, for instance. That's got to be broken down first. It's not ready uptake for the plant. That's kind of what I was just saying. Importance. When you know about the importance, you get losses. It's the imbalances start to happen. Excuse me. Your response. Well, that just shows you that if at point A, give it more. Point B is the max. If you give it too much, it's going to keep. It's just not going to yield more. We went through that before. Micronutrients. This is rad. This changed too. There used to be 5 immobiles. Now they've got a variable mobile. So it's pretty easy to remember. So your calcium, boron, manganese, CBM. That's immobile. So it's very hard to get transfer through the plant. It's got to be lifted and actively taken through the plant. Variable mobile, yep, your copper, zinc, sulfur, molybdenum, and everything else is mobile. There's a shitload of mobile stuff. That's why a lot of things flush out of the plants pretty easily. Nitrogen, potassium, phosphorus, the first 3. And you get magnesium deficiencies in the leaves fast because of that too. Hidden hunger, I'm going to drink. It's when plants have enough food, but they show not the proper things. You got to work it out why. That's a bit of nutrient deficiency tracing. There's some terminologies. It's all, yeah, whatever. Mineral. This is rad down the bottom. This is something I learnt. So see down here, potassium is on the outside, and you'll notice you get crispy edges and it goes burnt. Magnesium won't get the burnt on the edges, and nitrogen won't get edges. They'll still have a bit of green because their chlorosis will start from the internal vein. Very rad. Because they all look the same, those 3. Nutrient cycling. This is how the plant gets nutrients, and how to get them through the plant, and how to get them into your rhizosphere, which is the area right next to the roots. So there's quite a few ways of cycling. So atmospheric, biological, fertilizer, synthetic fertilizer, farmyard manures, farmyard green manures, waste, and plant residues, which is the farmyard green manures. Removal. And this is how to remove them, which is really important because, as I said before, a lot of things are mobile, so they can easily be just washed out. Erosion, leaching's washed out, erosion's similar. Removal of nutrients from your soil. It's a shame they didn't have a soil one, but this is an underwater one, aquatic one, but it still shows how they cycle. So over here, the algae take the carbon, nitrogen fixing bacteria, they change from nitrogen fixation into ammonium, and then that's readily uptaked. That's going to be broken down further again to become assimilated, so it's ready for the plant, NO3. Soil solution, nutrient cycling, that's just how it all is. Everything's cation exchange. These things add up for your soil solution. Your cation exchange, your surface absorption, soil minerals, your organisms, and your organic matter. Organic matter is so important. That's how to remove it from the how to retain nutrients. So it's to do with your CEC, because you want to have the positive charge. Cations have positive charge, anions have a negative charge. So you've got to make sure that they have a good balance in your system. Because if you have an imbalance, that's when things won't bind to each other and they'll just not bind. So that means they won't hold there. It shows you how the CalMag, potassium, aluminium, and hydrogen, sodium, how they cycle through. So the root hairs, and it's got shitloads through there. And then they're in the clay particles, and they'll put out exudates, and then they'll swap them with the microbes in the soil. So they'll take up the exudates and then they'll replace them with what the microbes have produced, which will be the elements that are near them and that they have produced, and that'll be absorbed into the soil, into the hairs. I don't want to read all this. This is just, you've got to have a good CEC and organic matter. Exchangeable cations in the fields. This tells you about the bonding strength. So if you've got sodium and aluminium there, ammonium, sorry, how do you know which is going to stick to it? Well, there's a stronger one. So this is a strength value. So that's why in some soils you've only got aluminum, sorry. These are all laughing. Fuck, it's aluminium. From where I'm sitting. So if you've got calcium there, and aluminium, all of a sudden aluminium come along, and it just takes over its position and pushes out calcium and leaves it sitting there. So it can be just washed out, or it's not bound to anything. So there's a high chance it'll be lost in the pool. If two cations are present with equal numbers, it's technical. Chelates, this is to do with locking. So chela means claw in Latin. So that's just locking and holding on to a nutrient. So that's what you want to do with your organic matter and having a good cation exchange capacity. That's some interactions for some genes. Mechanisms, diffusion. There's two ways to get soil nutrients through your plants: diffusion and mass flow. Diffusion is when it slowly diffuses from one gradient through the other, like if you're doing in your ebb and flow, when it comes up and it slowly diffuses through the medium. And then mass flow is when you pour it through, mass flow. There's a dam. So there's some advantages to that and disadvantages. And as you know about the mobility for nutrients, so you can see in mass flow, it's a pretty efficient way of getting calcium through the system because it's very immobile. So if you try and do it with diffusion, look, good luck. So maybe you ebb and flow people might have more, need more CalMag. But yeah, that's what that shows. I was amazed at that. It's just something, if you want to really fine tune your nutrient cycling and get into your fertigation, which is not fertilization, it's fertigation, which is exactly what the plant needs. So there should be no outputs. This is something that you really, really got to consider. Look how old it is down the bottom, 1995. It's not new technology. Nutrients must dissolve in water to be taken up by plants. They move from the soil to the vascular centre, where they get through their translocation processes. Root volume, they're uptaked nutrients depending on relationship, metabolic energy. Okay, good. Passive versus active uptake. Okay. Well, passive needs energy, active, it doesn't matter. You don't. Carrier proteins. This is how some ways to get like calcium in there. You need to have a carrier protein in there, and that's 3 different ways it can get in there. I'm going to really skip this. Cation exchange. This is cool. This is the mobile and immobile nutrient cycling in the plants. So you can see on the right here where it's mobile, it's got a bigger space where the roots can absorb the nutrients. And look on the left here. That's its space. That's its rhizosphere. Right next to it, if they're not there, it can't find those nutrients. Very important for you to try and help them. Simultaneous mass flow. This mass for you nerds. Actually, skip. Ion uptake. Mineralization is very important. This is probably to do with your more with your getting your nutrients for your plants. So in your composting process. Mineralization, mobilization, turnover. So if you don't have the good CN ratio, you're not going to get the mineralization happening, because if you've got too high of a CN ratio, the decomposition is slower. So in other words, if you've got heaps of brown, heaps like 100 to 1, so heaps of brown and not much green, decomposition is going to be very slow. So you want the green to get the bacteria in, to get the cycling happening. That's sort of all that says. Understanding it. Yep, I've covered it. That's pretty cool. It just shows the different CN ratios, which you would have seen today in the video. Factors affecting the soil's ability to supply nutrients. So there's quite a few there. I'm not going to read them, but it's mostly if you've got dry, hot, it's the pH in the soil really. If your pH is out of whack, it's going to cause these things to happen. So you want to make sure you're in the sort of 6 to 7 range, 6 to 7.5 range that you're sourcing. That is, that's your starting mix. Because see, if you're not in the right, this is flowing pretty good. So if you're not in the right pH, these things are going to be locked out. So if you've got a pH of 5.5, you get all these bottom RADs. Look at this: magnesium, calcium, can't get it. Phosphorus, can't get it. It's unavailable. It's got to be raised up to the 6.5 for all of this to be raised, to be available. That's why you say you want your mediums about sort of, your 5.8 to your sort of 6.5, because that's the range in which everything is available for the plant in the pH. Because pH is the negative logarithm of the hydrogen or the protons. Importance of pH in plant nutrition. That was sort of covered a bit. This is a dynamic soil plant nutritional relationships explosion view. I don't want to explain. Do you want me to explain it? I can't even read, so I can't see his comments. Actually, I hope I'm speaking. I'm just going to pause this for a sec. Shit, imagine if I'm not speaking. That happened last week. Am I speaking? Hello? Yeah, I think I am. Oh, how do I get back there? Oh, shit. Sorry. Oh, there it is. Always getting better. Nutrient imbalance leads to soil health depletion. Yes. This shows down here that if you've got an imbalance, like with the microbes, for instance, like I was saying in that video that I posted earlier today, that this was what can happen. And here's a nitrogen. Look how high the nitrogen is. Very, very high. And they got an imbalance. So just by putting shitloads of nitrogen, that's not going to fix jack shit. Actually, we've sort of already covered that. But this is a proof. overuse and underuse isn't good. That's it. There you go. All done. Stop sharing. There you go. Is there any questions? There's some other cool stuff I could show you. We had some things about the VPD, about your, I suppose, how long's it been going for? 25. That was pretty short. All right, I'll show you some of this stuff about the VPD. Do you have any questions, guys, before I go on about that? I suppose I'll just scroll up a bit just to see if there's any. There you go, Mick. How long have you been in this field? Mick Stoned, 31 years, mate. Hey, Colin. The leaves also do outside yellowing. How you going, Aussie Auto? Everyone should. How you going, Boom? Stoner. Tassie, g'day. In dreams. How you going, ready to hit hot fire? Reloads. Hi. Didn't work. All right, no questions. I'm going to keep going on to the next one. I'll just skim over the next thing about the VPD, why it's, I've always said it's not that important, and this sort of proves it. Again, it's interesting. You don't have to do it. It's just, there's heaps of different ways to grow. Where is it? There, week 1, vegetable. Oh, this is about the senescence. Hang on, this isn't it. Oh, shit. I'm not sharing. Oh, that's good. Sorry, you have to bear with me. Week 1, we've been through that. So what was I going to talk about now? A few of my other classes have started up, so I'm a bit confused. Post-harvest operations was pretty cool. A few things about senescing. Should I go? I'll show you that. This is amazing. I've been doing some experiments with senescence on post-harvest cannabis operations, and it works. I've been getting respiration quotient. Jesus. Now my teacher's in this. So yep, g'day. I'll get to the respiration. You don't want to know the maths factors affecting respiration. So the temperature. So for every factor you go up, the temperature does affect. Let's get respiration. So cannabis respires after it has cellular activity after it's been cut from the plant. I've wondered this for a while and I've proved it. Now, with my CO2 meter, and it goes through its phase, and when after it's been cut, it's got to go through, and still cellular activity happens. Here is the chart. So the growth's there, and then when it's been ripened, then senescence. No, that's not it. After it's matured, no. I want the cut off the plant. Time of ripening, no. That's still on the plant. I'm sure there's a chart here that shows after the plant's been ripe. That's ethylene, and it's in conjunction. It works in conjunction with it. Transpiration. And it goes into this now. Water vapor pressure. Oh yeah, here's some VPD stuff. So the water vapor pressure is the equivalent pressure of the water vapor above the liquid. Oh, it doesn't say. It is the pressure of the water vapor molecules resulting from evaporation. So it's relatively, no, it's not inversely, it's relatively proportional to the outside humidity. That's what vapor pressure actually is. You already know that. Skin factors affecting the rate of transpiration. So your transpiration is when the stomata exit they respire, they transpire. So they'll go through their phase, their metabolic process, and that's when they'll put out their water. They, respire their CO2. These are the things that affect it. Now, come on, where's the cool bit? Remedies of minimizing transpiration. Condensation. No. Oh, I must be a bit. It didn't get to the thing I wanted to talk about. Significant rate of respiration. Because that's when. Hang on, was that what I was wanting to talk about? When it was respiring. That's how to test it. Yeah. Come on. Maturity. It's when it respires. That's when it's growing, though. Well, it still respires after it's finished. When it's experiment. That's how to test it. I'm a bit confused here. Sorry. All right, I'm going to stop sharing. Next thing, we'll get to that class that I wanted to show you. Is not that one there. Post-harvest operations. The one that I wanted to show you. Plant physiology. That's the one. Here you go. Week 2. So this goes through a little bit of as well, and then after this, it's all finished. Share again. This is my last thing, and then I'll be right to answer questions if you've got any questions. No. Micro, week 2. This is it. So this is a plant physiology. This just backs up the same thing again. Just that was all of the. These are all micronutrients. And no, I'm going to get onto the function of boron. No, I'm going to get out of this bit. That's how to transport there through the different gates, membranes. No, come on. Phloem tissue. This might be a bit more interesting. The xylem tissue and the phloem, that's the veins inside of the plant. How it gets its, this actually, yes. That's how it gets its water and liquids around it through its plant. And that's, it's dead cells, the xylem, and they are right in the center. That's why some of them are hollow and not, because they grow faster than some of the others. Anyway, get to the next bit. Phloem tissue. So this is getting to a pretty good point here, saying that the phloem fibers are in proportion to the xylem. The xylem, secondary. You get a secondary phloems when they go through the first stage of growth is primary, which is vertical, and then the secondary stage is where it goes sideways, where it starts to thicken up. And that's where you get your secondary xylem and your secondary phloem start to happen. Translocation. Everything's got a source and a sink cell. So when energy has taken in, it is going in through the source cells and it's getting translocated through to the sink cells. And the sink cells are roots, the seeds, the little tips, stuff like that. That's how that works. And the pressure works in through the plant, through the, we're going to come up to that, but not confused. Let's just keep in flow of the RNA. This shows that different, if you graft a plant, that the translocation of RNA gets into the next plant. So the RNA is the messaging signals, the M is messaging RNA, and MI is microRNA, and they can get into the plant that you've grafted onto. So you can, it's an easy way to put genes across through methylation. Long distance, that's sort of what I just said. Summary, swelling, that's cool. You know, if you ring it, that kills the plant. Like that, you've taken off its phloem on the outside. That's this way. Molecules move fast. This is inside of the plant again. No, we don't want to know that. Hair-like phloem and seed tubes. So there's different types of phloem sap that's inside of the plant, and they've got different amounts of different things. That's how the phloem sap's actually from the maple leaves, maple juice and stuff like that. So that's phloem sap. So this is what that's what we're talking about. Constituents, different aminos, rate of phloem sap. Yeah, the speed of the phloem is 5 centimeters to 20 centimeters an hour. 2 inches to 6 inches an hour. Phloem sap as insect food. Yeah, so aphids as an example, they're a phloem feeder. They'll come in and, has it got it there? There it is, aphids. I think it's its ovipositor. It goes through into the phloem, and that's how it gets its feed. So if it's got anything bad in it, that's how it can stick into there. It goes into the phloem, gets translocated around the body of the plant. So that's how it gets its viruses and stuff like that, whatever would be in that pest. Brix value. I've got a value thing coming up on a video I've already made on Brix with cannabis. It should be coming out in the next few weeks. Organic acids, sugar in the phloem, feedings. Oh, there it goes. That shows the aphids right there. Ovipositor, I think it's called. Nutritional value of sap. Yes, it's very, very nutritional. That's why maple syrup's there. You know, that's why they go and bottle it. It's actual sap. Cellular change in aphids. No. Ross generation, reactive oxygen species. These are all the bad things that you don't want. They cause all the problematic things. All cancers in humans. Anti-proteins, the viral. All right, I think I'm nearly at the end, guys. If you've got any questions, you're ready to pump them out. I'm going to finish here. Oh, no. I want to tell you about the difference in the pressure on the outside. Didn't come to that. The VPD pressure. That's the end of it. Photosynthesis in the future. Yeah, that's how they can harness the energy. Actually, I've got a senescence video coming out too. I've got about 5 or 6 videos already made, getting released, and I'll do one each Saturday for the next 5 weeks, and then after that, I don't know what I'm going to do. See how things go. Don't even know if I'll do this anymore. I want to talk about the different pressures inside and outside, because they're directly related to and that's what I was getting to with that. I thought I was getting to that. I'm all confused again. Oh, this sucks. I've got to show you something while I talk, though. Foliar sprays. Sorry, confused again. I want to talk about the VPD, though, and just how it's directly proportional to the outside pressure. So what happens is the plant is, if there's no pressure happening, I want to show you while I talk. There's something. I'll get at least something up. If there's no pressure happening outside in the plant, how can I say this? The photosynthesis. Actually, I'm confused again. Stuff it. Any questions? I'll put the link up if anyone wants to come up and have a share invite. If anyone wants to come up and have a smoke or ask any questions, I'll be shutting the stream down very soon. There's the link. Let's go through. Yep. What's the different color sap? What's the different colored sap? That represents different constituents that's in the sap. So there'd be different flavonoids and things like that. That's what Jeff said. I'm just going to row up again and see if there's any. I'll put another screen on for you to look at. There you go. Let's look at some resin. Yes, all good. Aussie fan. So if you're top wrong, those can be opened up and hurt the plant. Also, if you top wrong, yeah, well, topping's not really, it always stunts the plant anyway, because you cut off the oxygen flow. So if you go on top, the oxygen gets made in the top of the plant, the shoot apical meristem, and then it gets, it's in a polar direction, gets taken down to the roots. So if you go and top it, it's going to create those paths again. So it will have a few days of stress from doing it that way. What's Aussie Grow Show? I have used tree sap melted down with boiling water. Yep, see, tree sap's very, very, heaps of good nutrients in it. Heaps and heaps of good. That's right. All right, you guys, if any other questions? So I'm going to end at, I think it's been enough. The classes I did this week were soil fertility and fertilizers, post-harvest operations and production of cereal crops and grain crops, the plant physiology and metabolism, and was that it? On entrepreneurship didn't start, and disease of horticultural crops, that one had a bit of a fault in it. Yeah. So it's not, so that's good. So I'll be doing that next week again, and seeing you here next week again, I suppose. If you've got any questions, you're welcome to throw them my way. There's a community in YouTube. You can always post stuff there, not post, but ask questions there too. Thank you for the questions that have been asked, and if you've got any more, please save them, because I can show you with all my slides the answers, or at least try to answer the questions. I'm not a genius or anything like that, but I just focus in this area, so I've got a keen interest in a lot of slides saved. So there's a high chance that I can at least nut out the question or try and get it out. And then if I don't know it, I can maybe ask my teachers like I've done in the past, because I'm still studying. I love studying. So thanks everybody. I hope you have a really good day. Thanks for rocking up and putting the effort in, time listening. Cheers to all yous. I'll speak to you next time. Happy breeding, happy growing. Bye.